All right, let's take a look at example 2. The base of a solid S is a circle of radius 1. For this solid, the cross-section slices perpendicular to the x-axis are squares. Find the volume of the solid. Let's start with what we have. Let's look at a picture. So we have this circular base, and coming up out of that circular base are these squares. And I want you to imagine infinite number of squares filling up this space. These are just a few samples. Now, looking at this from above, so two-dimensional perspective, we've got this circular base, and this red line represents a sample square. Okay, now let's pull that sample square out. And this sample cross-section, we can see has this base here that is this distance here of this red line across. Now, we know from the top of the circle to the x-axis, that distance is y. And then from this x-axis down to the bottom, that distance is also y. So we then could say this entire distance, this base of the circle, or sorry, base of the square that's sitting in this circle is 2y. Okay, now we know that squares have equal sides, so we know that the area of this square is just 2y squared, or 2y times 2y, or 4y squared. Now, just like before, the goal is to get this area function in terms of x. So if we look over here at our two-dimensional model, we see this triangle, right, relating our x and y. We know the bottom of the triangle here is x, and the vertical distance is y, and this diagonal here for the triangle is the radius of that circle, which is 1. So we know that x squared plus y squared is 1 squared, or y squared is 1 minus x squared, or y is the square root of 1 minus x squared. Now, using this information, we're able to rewrite our square function, our area function, in terms of x. So we're going to take this square root of 1 minus x squared and replace the y. So the area of the square is then 4 times the square root of 1 minus x squared squared. And just like before in the previous example, the square root and square are inverses, so they cancel each other, leaving us just with the area of the square is just 4 times 1 minus x squared. Now, remember, our objective is to integrate all of these squares, right? Stack them all up vertically across the space here, in this case from -1 to 1. So we get the volume is the integral from -1 to 1 of all of these areas of all these cross-section squares. So this is the integral, -1 to 1 of 4 times 1 minus x squared dx. Now, pulling that constant to make for an easier integration problem, we get 4, and then the integral of -1 to 1 of 1 minus x squared. The antiderivative of 1 is x, and then the antiderivative of x squared is 1/3 x cubed. So this is what we get. And then I'm going to go to the next slide, and we're going to continue. So we stopped here, and now we're going to evaluate. So this antiderivative at my upper bound minus my antiderivative at my lower bound. Here, 1 cubed is 1 times 1/3 is 1/3. And then over here, -1 cubed is -1 times -1/3 is +1/3. 1 minus 1/3 is 2/3. And then over here, -1 plus 1/3 is -2/3. 4 times 2/3 is 8/3. And then -4 times -2/3 is 8/3. 8/3 plus 8/3 is 16/3. So then the volume of the solid S is 16/3.